Now let's learn how to draw the orbital overlapping diagram of SCl6. First, we must have Lewis structure of SCl6. This is the Lewis structure of Cl6. From the Lewis structure, we determine the electron group of the central atom. So now our central atom is S. So it has 6 electron group which indicate it is sp3d2 hybrid. sp3d2 hybridization, the electron group arrangement is octahedral. Okay, now we will draw the sp3d2 in the arrangement of octahedral. Okay, this is sp3d2, so we have to label all the loops here. Right, this blue one is sulfur hybridization. Okay, now we look at our Lewis structure. We have 1, 2, 3, 4, 5, 6 sigma bond. We have 6 SCl sigma bond. So when we have 6 SCl sigma bond, we will show the overlapping orbital diagram of sp3d2 with 3p orbital of chlorine. So it will overlap end to end. This is 3p. Okay. Of chlorine. Okay. Next is we will show the electron. The electron is at the overlapping here. So this is orbital overlapping diagram of SCl6. For ICl2 minus, this is the Lewis structure of ICl2 minus. Now let's determine the type of hybridization of the central atom. So I here has 1, 2, 3, 4, 5 electron group. Indicate it has sp3d hybridization. Now for sp3d hybridization, we know that the arrangement will be the trigonal bipyramidal. Now let's draw the orbital overlapping diagram. We will start with the sp3d of iodine. Actually, it is not iodine. Okay, take note, if your molecule is an ion, so you have to consider the charge of the ion, the central atom here. So now the formal charge of I here is 7 minus 6 minus 2. It will become negative 1 formal charge. So now the sp3d hybrid itu adalah kepunyaan I- central atom. So now we will draw the trigonal bipyramidal arrangement. Okay, this is I-, kepunyaan I-, sp3d, label all the lobes. And next, look at the Lewis structure. From the Lewis structure, we have 2 sigma bond and we have 3 lone pair. 2 sigma bond and 3 lone pairs. Even though the arrangement is trigonal bipyramidal, but the molecular shape is linear shape. So the electron will be at these lobes, because if you remember the trigonal bipyramidal shape, these 3 lobes is at the triangle plane. So we will substitute the bond at this triangle plane or trigonal plane with our lone pair, and the sigma bond, ICl sigma bond, at these lobes. So the first sigma bond is I-, sp3d of I- overlap end to end with 3p of chlorine. So we will draw the 3p of chlorine. It will overlap end to end. So this is 3p chlorine, and now let's label the sigma bond. Okay, so this is the orbital overlapping diagram for ICl2 minus. For ICl4 plus, this is the Lewis structure of ICl4 plus. And now we calculate the formal charge for the central atom first. 7 minus 2 minus 1, 2, 3, 4. So the iodine in this ion will have positive 1 formal charge. So now we consider the type of hybridization for our central atom. So it has 1, 2, 3, 4, 5 electron group. Indicate it has sp3d hybridization types. Now let's draw the sp3d of I+. So the sp3d arrangement will be the trigonal bipyramidal. So we will draw trigonal bipyramidal. Okay, this trigonal bipyramidal is I plus hybrid. Now we label sp3d. Okay, next we will show the bond formation in the orbital overlapping diagram. From the Lewis structure, we have 1, 2, 3, 4 sigma bond and 1 lone pair. We have 4 sigma bond and 1 lone pair. So when we have 4 sigma bond and 1 lone pair, the molecular shape will become the seesaw molecular geometry. So 1 lone pair at the plane, triangle plane here, will be 1 bond at the triangle plane will be substituted with the lone pair. So another 4 lobes will form the sigma bond with Cl. So sp3d of I plus will overlap end to end with 3p orbital of chlorine. Okay, so this is chlorine. So 3p of chlorine. And next, we will label the electron and the sigma bond. Right. So this is the orbital overlapping diagram for ICl4+. For CO2 molecule, this is our Lewis structure of CO2. Look at CO bond. We have two types of bond. Here is 1 pi and 1 sigma. This also have 1 pi and 1 sigma. So if your molecule have this multiple bond, so we will show the hybridization for both central atom and the terminal atom. Now let's recalculate the electron group to determine the types of hybridization for the central atom and terminal atom. So for carbon here, we have two electron group. So it is sp hybrid. For oxygen, first oxygen, we have three electron groups. So it is sp2. This also sp2 hybrid. Now, let's redraw the orbital overlapping diagram for this CO2. We start with drawing the sp of carbon first because it is the central atom. So we will draw sp. The arrangement is linear. Okay, so this is sp of carbon. Okay, now sp of carbon will form the sigma bond with this O. So O here, the orbital involved is 2p orbital. Now the 2p orbital, the shape is the dumbbell shape. So we draw it overlap end to end with oxygen 2p orbital. This is the electron sigma bond. And now we show the second sigma bond, sp of carbon with 2p of O. So this is sigma bond. Alright, so now we settle for the sigma bond. Now let's show for the formation of pi bond. So since carbon is a 2p orbital, will be used for the formation of pi bond with oxygen. So for the pi bond, it will overlap side to side. Now we will draw the first pi bond, 2p of pi bond, 2p of carbon, overlap side to side with 2p of oxygen to form the first pi bond. So the electron is at this lobe. This is pi bond, the first pi bond, while the second one is another 2p of carbon with the different orientation from the orange one. So it must have the same orientation with 2p of another oxygen. So the electron here, right. So this is our pi bond between C and O. So let's finish our orbital overlapping diagram for CO2 molecule. For C2H2 molecule, this is our Lewis structure of C2H2 with CC triple bond and CH sigma bond. This is the hybridization process of our C in the molecule. Okay, now we will draw the orbital overlapping diagram for this C2H2. From the Lewis structure, we already know that our carbon, our central atom, will have sp hybrid, and this also have sp hybrid. And from this triple bond, we know that we have 2 pi bond and 1 sigma bond. And between C and H, we will have sigma bond. Now let's draw the sp hybrid of this carbon first. Sp, the shape is linear, so we have, this is our first carbon, sp, sp. Next, we will show the sigma bond between this carbon and this carbon first. Since this carbon also is sp hybrid, this carbon also has sp hybrid, so sp of this carbon will overlap end to end with sp of this carbon. So I will use another color for the second carbon. This is sp for another carbon, and the electron is here in the sigma bond. So we have settled our sigma bond, CC sigma bond, which sp of carbon overlap end to end with sp of another carbon. Now let's show the formation of sigma bond, CH sigma bond. So this CH sigma bond form when sp of this carbon overlap end to end with 1s orbital of hydrogen. So 1s of hydrogen, this is the first hydrogen, so the electron is here and the sigma bond is formed. And now for the second hydrogen, CH sigma bond, also the same way we have to draw, which is sp of this carbon overlap end to end with 1s orbital of hydrogen, and the electron is at the overlapping here. So now we settle with 3 sigma bond in this molecule. Now let's draw the pi bond. Pi bond formed between carbon and carbon. So if you look at the hybridization process, we have 2 single electron which is unhybrid, which is located in unhybrid 2p orbital. So this electron will be used for the formation of pi bond. Now we will draw the first pi bond. Okay, let's say you know that 2p we have px, py, pz. Okay, let's say we already use this px to make the hybridization here. So left over here is py and pz. So 2 different orientation. We will use first orientation for the formation of first pi bond. So I will use the orange one to show the first pi bond between this carbon and this carbon. So this is py. Okay, 2p of this carbon overlap with 2p of another carbon to form the first pi bond. So the orange one, I'll use the 2py orbital and the electron here. Okay, and the second pi bond, I will use the pz. So the different orientation with the orange one. Okay, so this is 2p of carbon, is also 2p of carbon, overlapping side to side, forming pi bond. So the electron is here. So from the orbital overlapping diagram, we can see that CC sigma bond, if I can write here, we have CC sigma bond, we have C pi bond. We also have CH sigma bond. So CC sigma bond is formed when sp of carbon overlap end to end with sp of carbon, the second carbon. Okay, while CC pi bond 2p of carbon overlap side to side with 2p of carbon, while CH sigma bond form when sp of carbon overlap end to end with 1s of H. So we settle the overlapping orbital diagram for our C2H2 molecule. For C2H4 molecule, this is our Lewis structure, and this is the hybridization process of our C2H4. Now we will draw the orbital overlapping diagram of C2H4. From the Lewis structure, look at, we have two central atoms here. So for the first carbon, the type of hybridization is sp2 because it has 3 electron groups. Same goes to this carbon, also sp2. Now we will show the orbital overlapping diagram of our molecule. We start with our first carbon, sp2. The arrangement will be the trigonal planar. So we draw the trigonal planar shape first. This is sp2 of the first carbon. And now we will show the overlapping with this sp2 of the second carbon, forming the sigma bond first. Okay, you know that for the double bond we have 1 pi and 1 sigma. We will show the sigma bond first. sp2 of the first carbon will overlap end to end with sp2 of another carbon. sp2, and the electron is at the overlapping here, forming sigma bond. So we settle for our sigma bond, CC sigma bond. Now with CH sigma also forming sigma bond here. Now we will show the sigma bond between C and H. Hydrogen, we know that it has one s orbital, so sp2 of carbon will overlap end to end with one s orbital of hydrogen. Same goes to the second sigma bond. This second sigma bond, one s of H overlap end to end with sp2 of carbons. So label electron and label the overlap, the type of bond. We go to the next sigma bond between C and H here. So same goes to this sigma bond, sp2 of carbon also overlap end to end with 1s of hydrogen. 1s of hydrogen, and we will label the electron and the sigma bond. I forgot to label this carbon. Okay, now we settle the sigma bond, CC sigma bond and CH sigma bond. Now we will show the pi bond between the first carbon and the second carbon. Okay, from the hybridization process, we can see that there is unhybrid 2p orbital will be used for the formation of pi bond. So it will overlap side to side because it is pi bond. Alright, so settle the orbital overlapping diagram for C2H4. Now look at the diagram. From the diagram, we have CC sigma bond, we have CC pi bond, we also have CH sigma bond. Now you need to explain how the CC sigma bond form when sp2 of carbon overlap end to end with sp2 of another carbon. Okay, for the CC pi bond form when 2p of carbon overlap side to side with 2p of another carbon, and CH sigma bond form when sp2 of carbon overlap end to end with 1s of hydrogen. So finish the orbital overlapping diagram for the molecule of C2H2. Okay, that's all. Hope you learned something from this video, and don't forget to make correction if you made any mistakes. Okay, bye.